A relation and its inverse will undo each other. And we accomplish this by switching the x and the y. So somewhere on your notes, I want you to write that an inverse means that we are going to switch x and y. When we find an inverse relation, so here's this table of values. The first point in this relation is -4, 2. The first point in the inverse relation would be 2, -4. So if the second point is -2, 1, what do you suppose the second point of the inverse is going to be? 1, -2. 0, 0 will become 0, 0. Oops, I did not make enough things on my little chart here, did I? I'm good at that. 2, 1 is going to become 1, 2. And 4, 2 will become 2, 4. There is the inverse relation to that original relation table of values. So if I give you a table and ask you to find the inverse, it's pretty easy. Just write a new table, switch the x's and the y's. If we're finding the inverse of an equation, here's the steps we're going to follow. Our first step is we switch x and y. That's the actual process of inverting. Switch the x and the y. And then step 2 is solve for y, which basically means get y by itself. Number 2, find the inverse. Our first step is switch x and y. So y becomes x becomes y. Then we need to get y by itself. What do you think we should do first to get y by itself? Add 4 on both sides. So we have x plus 4 equals 2y. And then divide by 2. Now when you divide by 2, you can do this several ways. You can divide the entire left side by 2. So our final answer is y equals x plus 4, the whole thing divided by 2. Or you can divide each thing in this equation by 2. And sometimes one method is better than the other. So I'll put the answers both ways. So this would be x over 2 plus 2. Either of these would be considered correct answers for this particular problem. How you format the answer honestly kind of depends on what you intend on using that equation for. So whichever way you prefer doing that is fine. Number 3, first step, switch the x and the y. Y becomes x becomes y. To get y by itself, we start by adding 7 on both sides. How do we get rid of times 2/3? Times 3/2. So you're going to multiply this entire right side by 3/2. We're going to multiply the entire left side by 3/2. Now when we're multiplying by a fraction, I am totally fine with you leaving this as 3/2 times the quantity x plus 7. And you can put the equals y on the right side, or if you want to make it look extra fancy, put the equals y on the left side, just because that looks nicer and more finished. Two functions are considered inverses of each other if f of g of x is the same as g of f of x. Remember yesterday we talked about f of g of x and g of f of x are not the same because the order that you substitute one function into the other definitely matters. With inverses, that order will not matter. They will be the same, and they will end up equaling plane x. Basically, the two functions will completely undo each other. So, verify that f and g are inverse functions. We need to do f of g of x. So, if f of x is this one and g of x is this one, I need to do 1/3 times something minus 1. That something is 3x plus 3. What is 1/3 times 3? 1. So this is 1x plus 1 minus 1. The plus 1 and minus 1 will cancel each other out, and we simply have 1x. The 1/3 and the times 3 canceled each other out. The plus 3 after it was multiplied by 1/3 and the minus 1 canceled each other out. These two functions are going to cancel each other out every time and leave you with just plain old x. We'll go over number 5 in the video tomorrow, so we'll talk more about this tomorrow because this is actually part of your assignment tomorrow. Okay, we're pretty familiar with this symbol, right? F of x means f of x. This symbol means f of x. This symbol with a little -1 in there means f inverse. Or you could just say the inverse of f. That little -1 in between the f and the x indicates that that particular function is going to be an inverse. Okay, on the next page, number 6, we're going to find inverses, but this time it's written in function notation, which is a little bit funky. You just need to remember that f of x equals is the same as y equals. So honestly, what I do when I'm finding the inverse when it's written in function notation, I just take this f of x and I turn it into a y because it's the same thing as a y. Our first step when we find inverses is to switch x and y. So that f of x, which is a y, becomes x becomes y, and there's this little extra tidbit of information that we're just going to save for later right now. Okay, we need to get y by itself. How do we undo a square? Square root. And when we put a square root in, we have to put a plus minus in front of it. So, on one side of the equation, the square root of y squared is simply y. The other side of the equation, we have plus minus the square root of x. Now I want to talk to you about what this little extra tidbit of information means. X is greater than or equal to 0. Does that indicate positive numbers or negative numbers? Positive numbers. This little tidbit is saying we want positive x values. They're basically saying that they only want the positive square root. So this little information is telling us in the plus minus symbol, we only want the plus. So our final answer is going to be y equals the positive square root of x. All right, let's try number 7. Oh, and technically, because this problem started as function notation, we probably should write our answer f inverse of x equals the square root of x. That actually is the most correct answer. I'm not going to be super picky if you forget that. Okay, number 7. This f of x means y. So we switch x and y. We've got x equals 3 times y to the 4th. Save this little tidbit of information for later. How do we get y by itself? Divide by 3. So we have x divided by 3 equals y to the 4th. How do we undo an exponent of 4? A 4th root. And that's an even root, so we have to put a plus minus in front of it. So we've got positive or negative 4th root of x over 3. The other side of the equation is y. Now let's go back and think about this little extra piece of information. X is less than or equal to 0. Does that indicate positive or negative? Negative. So which part of the plus minus symbol do we need to keep? The minus. Our final answer is y equals the negative 4th root of x over 3. Or we probably should write it as f inverse of x equals the negative 4th root of x over 3. I would accept either of those answers from you. When I look at number 8, I notice that there isn't that little extra piece of information over here on the right. Why is there not that extra piece of information on this particular problem? It is a cube, which means you're going to end up doing a cube root, and you're not going to need the plus minus. So that little tidbit of information is included on any problem where you need to put a plus minus in there. They're telling you which part of that plus minus symbol to use. So this one won't need it. I want you to try number 8 on your own. Pause the video, give it a try. Okay, I switch x and y. I subtract 5 on both sides. When I get to this step and I'm dividing both sides by 2, you could divide everything by 2. You could just put the entire left side over 2. Because I know that my next step after that is going to be taking the cube root, I'm just going to put the whole thing over 2 and leave it nice and compact like that, so I don't have to worry about a whole bunch of extra stuff. So y equals the 3rd root of x minus 5 over 2, or if we want to write it in function notation, f inverse of x is the 3rd root of x minus 5 over 2. Tomorrow, the video is going to cover verifying that they are inverses again, and the horizontal line test. I'm hoping that the video will be about 5 minutes or less. There's also 1 or 2 problems on the assignment that I'm going to cover on the video, so make sure that you watch the video tomorrow on our Wednesday. Your worksheet today is 5.6 day 1 worksheet. Tomorrow you'll have 5.6 day 2 worksheet.